the next terms for arithmetic sequences, and this is actually really easy because as soon as you know the common difference, so for example here we're subtracting 6 every time, then I just start with my first term, subtract 6. Here's my next term, negative 9. Subtract 6 from that one, there's my next term, negative 15. So to get the next three terms, I just have negative 9, negative 15, then I'd have to subtract 6 one more time and get negative 21. The pattern just keeps going. Notice it's still minus 6 every single time. Finding the next terms is actually one of the easiest things you can do with these arithmetic sequences. Now, if you want to find the nth term, this is basically saying an nth term of an arithmetic sequence just means if I want to find any term. So I could find the 2000th term or the 100th term. And if I want to find the 100th term of a sequence, you could do this. I could just keep adding d, so I'd keep adding, this example, 3 every time. But you wouldn't want to do that 100 times to find your 100th term. So what we can actually do is we can take this general pattern. Notice I just keep going up by 1d every time. I add another term. I add another common difference. So we can actually use that to get this general formula for an arithmetic sequence. And you're going to need to memorize this. Okay? A sub n, this means just any term, equals a sub 1. This is my first term. Plus n minus 1 times d. This is my common difference. This is how we write an equation. And we can use this to then write an equation, and I could find the 1000th term just as easy as plugging in 1000 for n. It actually becomes quite simple. So let's look at our next example. We want to write an equation for the nth term of the arithmetic sequence. First thing we got to do is find the common difference. Well, what's happening every time? I'm going to add 4 every time. So once you find the common difference off to the side, just write d equals positive 4. We are increasing by 4 between each term. That's the common difference. Once you've found the common difference, you've done the absolute hardest part. Now to write the equation, a sub n equals a sub 1. This is my first term. Well, that's negative 12. Plus n minus 1 times d, which is 4. All you have to do is you plug in n minus 1, or a sub 1, which is your first term, and d, which is your common difference. That's all you have to do. It becomes super simple to do that. So now I can find the 9th term of the sequence because I know a sub n equals negative 12 plus the quantity of n minus 1 times 4. To find the 9th term, that would be a sub 9. Notice the 9th term, instead of the nth term, I'm plugging in 9 for n. This is not a times 9, this is a sub 9, just a label, equals negative 12 plus, and I'm plugging in 9 for n minus 1, which is now 9 minus 1 times 4. So a sub 9 equals negative 12 plus 9 minus 1 is 8 times 4. A sub 9 equals negative 12 plus 8 times 4 is 32, which negative 12 plus 32 is 20. So what is the 9th term in this sequence? Oh, it would just be 20. And you could have done that by just counting plus 4, plus 4, plus 4, plus 4, plus 4. But if we just use our equation, we can do it a lot faster. And then I can say which term in the sequence is 32. Well, I want to know what is going to give me which a sub n would equal 32. So I'm going to plug 32 in for a sub n because I know this is what I want to end up with. And I'm going to say that equals negative 12 plus n minus 1 times 4. Now I'm going to solve this equation. First thing I have to do is distribute. 32 equals negative 12 plus 4n minus 4. I'm going to combine my like terms on the right side. Negative 12 minus 4. Please do not just say this is negative 8. Okay, negative 12 minus 4 gives me negative 16 plus 4n. Then I'm going to add 16 to each side. I get 48 equals 4n. Divide each side by 4, and I get 12 equals n. What this means is that n is the number of sequence I am. So a sub 12 equals 32. Notice I just replaced the n with the 12. And what that means is, which term of the sequence is 32? It would be the 12th term. And the way we found that, we took 32, plugged that in for a sub n, and then solved for n. So we were able to figure out which term of the sequence would be 32. If they give you the term, you just plug that in for n. If they tell you the number you're looking for, you're solving for n. Two different ways to do these problems.